Assalamualaikum and hello. I'm going to focus the next comparison of boiling point for case 4. If you see here, you got 4 different compounds. The first one is W, X, Y, and Z. So how you want to compare? Just as before, determine what forces they can form. So W, if you see here, you got carboxyl group. So it means that you can form hydrogen bonding with dimer. So I'm going to put short form Hb plus dimer. And after that, for X, you can see that X got OH group. So this is hydroxyl group. So X can form hydrogen bonding only. One more thing that you have to indicate here, X got one OH group only. So if you take a look next one, Y, you got 2 hydroxyl groups. So it can also form hydrogen bonding. But right now, the number of hydroxyl group is 2. And last one, you got structure Z, which is 1 hydroxyl group. So this one can also form hydrogen bonding with 1 OH group. So when you want to talk about the comparison between X and Z, it got both the same similarities. So what can we do? We are going to compare the molecular weight. If I label my numbering for the carbon, I got 6 carbons for X. So 6 carbon atom for X. And then for Z, I got 1, 2, 3, 4, 5, 6. Same goes for Z, 6 carbon atoms. So they still got the same similarities. So in this case, the last resort, we are going to compare based on their surface area in contact. If you see here, X is a straight chain, but right now Z has branches. So we are going to compare based on surface area in contact. So I'm going to put the point X is a straight chain while Z has branches. So you can conclude the conclusion right now. Which one is the highest boiling point? We are going to do the arrangement in decreasing order. So I'm going to start with the highest one. So the highest one will be W because it can form hydrogen bonding with dimer. So W is the highest one. And then you have to use greater than for decreasing order. The second highest boiling point will be Y because Y, you got 2 hydroxyl groups. So I'm going to put Y greater than. Between X and Z, you can see that X is a straight chain while Z has branches. So of course, X has larger surface area in contact, hence higher boiling point than Z. So the next one will be X greater than Z. So this is my arrangement. So I'm going to write down 3 paragraphs based on my arrangement. Let's do them one by one. So I will choose the first paragraph between W and Y. So the first point, as usual, talk about their forces. So my first point, I'm going to choose Y can form hydrogen bonding, if you see here, while W can form stronger hydrogen bonded dimer. That is my first point. And the next point, you can say that W has higher boiling point than Y. Settle for the first paragraph. Let's go to the second paragraph between Y and X. So if you take a look here, Y contains 2 hydroxyl groups, but X contains 1 hydroxyl group. So the first point, you can talk about their number of hydroxyl group. So the first point is Y has more hydroxyl group than X. Hence, Y can form more hydrogen bonding than X. So the second point, you can say that Y has higher boiling point than X. So in this paragraph, what I want to see is the term more here and more here, so that you can indicate due to the presence of more hydroxyl group can contribute to more formation of hydrogen bonding. Let's go to the last paragraph between X and Z. So as I mentioned before, we are going to compare them in terms of surface area in contact. For example, I choose Z as my subject, so I can say that Z has smaller surface area in contact than X. So that will be my first point. And after that, I will compare the forces for them, which will be London dispersion forces. Why I'm not going to use hydrogen bonding? Because both of them can form the same amount of hydrogen bonding due to one hydroxyl group. So that's why I'm not using hydrogen bonding. Instead, I will use weaker London dispersion forces for Z compared to X. So the second point, I can say that Z can form weaker London dispersion forces than X. So this weaker London dispersion forces here is referring to the arrangement of their alkyl groups here and here. And last point, don't forget to write down that Z has lower boiling point than X. So settle for the explanation of boiling point based on case 4 when you have 4 different compounds that you want to determine which one is the highest boiling point. So I hope all of you are clear how to describe and do the explanation with correct comparison for the boiling points of the compounds given. So that's it for this video. We will catch up with the next physical properties in the next video. Thanks for watching. Bye.